So today we're going to take a peek at multiplication and division of integers. And we've already discussed how to add and how to subtract and all the rules that are involved and all the things we need to pay attention to. But what I think is multiplication and division is actually just a little bit easier on our heads, right? We can wrap our brain around it just a little bit. And the way that I like to do this is I like to think of a light bulb. All right. So let's imagine for a moment that we have some sort of light. Okay. And so we have our, let's make a little switch. All right. And we're going to put another switch over here because we've all been in this situation where we have somewhere, all right, somewhere we have our light. And we are in a dark room and we have a switch, and this switch could be either up or down. And let's say that they're both pointed up right now. And when they're up, we're going to say that this light bulb is off. But if someone comes through and somebody takes our light bulb, oops, or our light switch, I should say, not our light bulb. And let's pretend that they move it now down. When they move it down, the light bulb turns on. And now we have light. And when they walk out on the other side, see right now we have one down and one up. But when they walk out on the other side, they then go ahead and they flip the other light switch down. And now both light switches are down, and therefore our light goes back out. So what we're getting out of this is that when the light switches are in the same direction, that the bulb goes out. But when there's only one up and one is down, the light bulb turns on and there's power that's allowed to flow through there. The same thing is going to hold true with our negative signs. So let's think of this as a -5 because it's pointed down. Let's say -5 multiplied by -2. See, since they're both down, they're both negative, this answer, these negatives are actually going to cancel out, and our answer is a +10. Our light bulb is off. Now, what would happen if we happen to move one of these switches up? What that means is that it's positive. So we're taking away one of those negatives. So up, the light bulb comes back on. When it's one up, positive, one down, negative, it's now negative. And that's what we're looking at here. We are looking at the idea that if the negatives balance themselves out, if there is an even number of negatives because they cancel, then it becomes positive. But if there's an odd number, one light switch is up, one is down, then we have power. We have a negative number. So let's pretend that that person came in and they're going out on the right-hand side here. So they get rid of this negative. They flip the light switch again. Now the light switch is up, positive, positive. Our answer is going to go back to positive. And we can keep flipping back and forth. The light, of course, would then obviously be, I should erase that, would turn off because they're in the same direction. So let's look at what this means. What does this mean when we talk about numbers? So if I were to multiply -6 times 4, what we're saying is that there is an odd number. There's only one negative. So it goes negative, multiplied by a positive, nothing changes it, so it stays negative. And then 6 times 4 is 24. If I started with a 6, I multiply it by a -4. So let's pretend for a moment that we're going to multiply it by a -4. We're saying it started as positive, but we have a negative here. It became negative. 6 times 4 is 24. So there's only one negative. or we would say there is an odd number of negatives. So an odd number of negatives, the answer stays negative. But let's take a peek at this. What if I started with a negative and I go ahead and I multiply it by another negative? Negative times negative. Well, it starts negative. We have another negative, which turns back to positive 24. So we have an even number of negatives. Now, some of you might be saying, well, okay, so that's easy. So you're saying if there's only one negative, then the answer is going to be negative. And that is true, but that's not what I'm saying. I'm saying if there's an odd number of negatives. Because check out this scenario. What if we have negative 3 times negative 2 times negative 4? Let's think about this. Odd number of negatives. There's 3 negatives. So if it's an odd number of negatives, we're anticipating the answer to be negative. Negative 3 times negative 2. Negative, negative, it becomes positive. Right? So negative 3 times negative 2 is positive 6. Positive 6 times a negative 4. Now it goes back to negative. So this is actually going to be negative 24 because there was an odd number of negatives. The beauty of this is the rule stays the same whether it's addition or multiplication or division. If we had negative 24 and we divide that by positive 3, there's a negative, but nothing turns it back to a positive, so we're left with negative 8. If I had positive 72 and I divide that by negative 8, the positive is turned into a negative by this negative 8, so the answer is negative. 72 divided by 8 is going to be 9. And it would make sense because if we went backwards, let's pretend we worked with our fact families here and we said that we have negative 9 times negative 8. That would negative times negative equals positive 72. So the only rule you really need to pay attention to for multiplying and dividing negatives is whether it's an even or odd number of negatives. Let's do one last example here. Let's pretend we have negative 1 times 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 negative 1. We know that 1 times 1 times 1 times 1 times 1 times 1 is going to be 1. But is it positive or negative? Well, 1, 2, 3, 4, 5, 6. 6 negatives, so it is even. Because it's even, it's positive 1. Now, if we had this situation, negative 1 times negative 1 times negative 1 times negative 1 times negative 1. 1, 2, 3, 4, 5. We have an odd number of negatives, so it's negative 1. I hope this helps shed light on some of the intricacies of multiplying and dividing with integers.